Alright, so today we're going to talk about functions in C++, so let's get started. So first we're going to talk about what a function is. We're going to talk about the syntax for a function, what function prototypes are. We're going to talk about default and reference parameters, and then lastly we'll talk about function overloading. So first, up to this point you may have had to, whenever you had to do something, the same thing multiple times, you may have had to just write that same code over and over again. And you may have ever wondered, like, if there is an easier way to do that so you don't have to write all that stuff out, which is so repetitive. And there is, and it's these functions. So with functions, you can follow the dry principle, which is don't repeat yourself. And a function it's a single block of code that can be executed multiple times throughout a program. So yeah, the function definition, that'll define your return type, your formal parameters, and the behavior of your function, or what you want it to do. And it has a header and a body. And then the function call is the point in your program where you actually execute your function, because up to that point, with your definition, nothing gets executed. But when you call it, that's when your function gets executed using actual parameters, if those are actually passed in. So yeah, here's the basic syntax for a function, which you should place before your main function, and we'll talk about why here in a second. So yeah, you have the return type, the function name, which can be basically the same as a variable name, same rules. Then inside those parentheses, you have the formal parameter type, and then the name for that formal parameter. And then you have curly brackets, and then you're going to have your lines of code, or what you want your function to do. And then lastly, you might have a return statement, which is returning a value to your whatever's calling it. So yeah, after you define your function, it can be called in other functions, including main, with the following syntax, which is just you put the function name and then the actual parameters in there if there are some. And that actual parameter can be a variable name or a value. So there's that. So yeah, functions, they can be fruitful or non-fruitful. So what that means is when we saw the return statement, talking about returning something, that's a fruitful function because it's giving something back to the caller. But non-fruitful functions, it means it's not giving anything back. And for these kinds of functions, then your return type is going to be void, and there's not going to be anything returned. So yeah, functions can have none or multiple parameters, but if it has multiple parameters, it's important to note that the order and number of parameters listed in the call need to match those in the header. And functions can call other functions, but the called function must be defined before the one that is calling it, usually. And that's we'll talk about kind of the somewhat exception to this here in just a second, actually. But yeah, this is why we're saying to define all the functions before your main function, because that's probably where you're going to be calling most if not all of your functions. All right, so before we do that, we'll look at some basic examples of functions. So I've already written some here. So first we have double number, and it takes an integer number in, and it'll multiply it by 2, and it'll return that integer. And that's so the return type is integer. And this is kind of a bad example of a function, because something this simple, you probably just do it outside a function. But here's a better example. Do something really crazy here, and it takes a double in and returns a double. And what it's doing here is just something random I made up. But you can see it's very messy. Trying to write this multiple times would not be fun. So this is a decent example of a time you'd want to probably use a function. If you want to do this, some kind of weird, crazy calculation multiple times. And then lastly, we have a kind of, I guess, an example of a void function. Maybe not the best example, but basically it's just a print statement, kind of similar to like if you've ever used Python before. Similar syntax to that kind of. And it's not going to return anything, but it has the cout in here, so it'll print something out. And I have already written some some examples of the calls here. So yeah, we got the name of the functions up here and the actual parameter we're passing in, which is just a straight value. But it could also be, as I said, a variable that you've defined with a value too. So we will compile and run now, and we'll see what we get. So yeah, as you'd expect, the double number just doubles it, and then the just do something really crazy here, gives these weird values, and then lastly, the print statement just prints this string out here. So we mentioned up to this point that functions need to be defined before any functions that call them, and that includes the main function. But there's kind of an exception to this if we want to circumvent it using function prototypes, which will declare the function, its return type, and the parameters, but don't feature the function body. The full function definition will still be present elsewhere in the program, but the placement won't matter then in that case, as long as the prototype is slated for any functions that call it. And the syntax is pretty similar to the function header, but afterwards, instead of having the curly brackets, you have the semicolon, and that'll end it there. And then using function prototypes, another advantage of it is that it also allows us to see our full list of functions without their bodies being in the way. So with that in mind, we can rewrite our code using prototypes. So what I'm first going to do is I'm just going to copy this to after our main function. And to convert these into prototypes, all we should need to do is get rid of the bodies and put a semicolon after the header part. Okay, now assuming we've done this right, this should work just fine. We'll clear this and we'll compile and run again. Yeah, same output. So yeah, we can see all our functions here without their bodies being in the way, and we can still use them in our main here with the actual definitions being below it. So now we have default parameters. So the thing with default parameters is that you can either use them in the function header or prototype, and what they will do is they will assign default values to the parameters in cases where the parameters aren't given any values in the function call. So yeah, to give a parameter a default value, you'll just put the equal sign and the desired default value after the parameter's name. Yeah, you should. I'd recommend putting your default parameters after your non-default parameters because the order still matters. And if you're using it for prototype, you only need to declare the default values in the prototype and not the actual definition, wherever that would be. So yeah, here we have an example of a function prototype using default values. Yeah, all three of our formal parameters have default values in the cases where they're not provided. So that might be helpful. So now we have reference parameters. And the thing is, when you normally pass variables to functions and you try to make any changes to them, they won't be saved outside the function because the thing is with the function is that it's only receiving a copy of the variables, and this is called passing by value. And that'll mean that your parameters outside the function will remain unchanged. But if you wanted to actually change the values of those parameters, there's a way to do it, and that's using reference parameters in the function header and prototype if it exists. And this is called passing by reference. So to declare a reference parameter, you'll just use the ampersand sign, which is like the and, which is just the and sign basically, between the parameter's type and its name. The exact placement doesn't really matter. You can have it right before the name, as I do here, or like right after the type of a space between. It doesn't really matter. That's how I like to do it personally. All right, so now we're going to do an example of reference parameters with this swap to numbers example. So we've already got the code and the main function kind of calling and testing it out here, but we still have to write the prototype and definition for it. So we'll do that really quick. So since we're going to be using reference parameters, we don't have to return anything, so we'll just have the return type void. We're passing in two integers, and we're passing by reference, so we're going to get our ampersand. And we'll do that for our other parameter. Here's our prototype. I'll just copy that down here. Get our body. So I guess here's a fun little mini lesson for when you want to swap the two values. So yeah, your first thought when swapping might be just to do something like this. But this wouldn't work, basically, because you're setting the value of B to the value of A. And now they both have the same value. So when you try to set A to the value of B, what you wanted the expected value be, it's still going to be the same value. Both of them are just going to have the value of B now, which isn't what you want. So what you're gonna in this case, you're going to want to introduce a third variable, a temporary variable, and you're going to set that equal to one of your values. Let's see. And then actually, in that case, you want to switch the values around, like this. All right, and now this should swap. We set the value of temporary to A, and then we set the value of A to B, and then we set the value of B to A's old value. And this should be a successful swap. So now we can test it. Compile, run. Yeah, so before we had X and Y, X5, Y10. We can see that here. And then we perform our swap. And afterwards, sure enough, our X is 10 and our Y is 5. So that's a successful swap. So lastly, we have a function overloading. So the thing is with functions is that multiple functions can actually share the same name as long as they have a different signature. And to have a different signature means that they have a different parameter list. And this is function overloading. So here is an example. Both of these functions are divide by, but one uses integers for its return type and its parameters, formal parameters, and the other uses double for its return type and formal parameters. So whenever you're calling it, whichever one it matches up to, like if you passed in two integers, you'll use the top one, but if you passed in two doubles, you'd use the bottom one. So that brings us to our practice. So for what I want you to do, I want you to write two functions that'll share the same name, so a bit of function overloading, and they'll both be used to update a set of Cartesian coordinates, x and y, but each will have a different approach. And the hint here is that one approach will require the function to be called twice, but the other approach will only need one call. So I'm going to start working on it here in a second. So if you want to do it by yourself, do it now. I'll have a time code on the screen for when we'll see the completed code if you want to compare yours to mine. So I'm going to start working on it right now. Alright, so first we're going to do our prototype for our function. First function that we will not be using reference parameters or anything for, so we're just going to have a thing here. So prototype. And I just realized this is actually this first example will be like really bad of something you don't really want to, kind of function you don't want to do. So the second one will actually, I think, be better. But we'll do this first one first. Yeah, this is literally, it's just returning the value, like, maybe the worst example of a function you could do, in fact. Just passing this in and returning it. At that point, you should just set it equal to what you're wanting to set that coordinate to, and this is the one you're gonna have to call twice anyway. So our second approach, which will share the same name but have different behavior because it's using reference parameters, I think is a much better use in this case. So it'll have the same name, but it'll be void, and we're going to use our reference parameters. See, x and y, wrong symbol. And then we need new values, new x and new y. And we don't need to pass these in by reference, but we have these ones passed in by reference. So that's our prototype. And we will define it down here. And we'll just simply set x equal to new x and y equal to new y. Okay, and that should do it, assuming I haven't done anything wrong. And then we'll just write some random code here. Let's see, int x equal 13, y equal 18, because why not? And our first one, which is kind of the bad example, really bad example, in fact, x equal update coordinates, and we'll use just 8, and y will update coordinates 5. So it's kind of a bad example. And then our second one here, we'll just only need one column. We don't need to set it equal to anything because we're using reference parameters. So we'll pass in x, y, and then our new values, our new x, 64, and our new y, 32. Why not? So there's that. And now we need to kind of, I guess, test that with some c-out statements. So x see, and then let's see, make a new line. Do this, and then we'll just copy this a couple times. So we have one after our initial declaration of the values, one after our bad way to do a function, and then one after, I think, kind of a better way to do it. So hopefully this will work. Hopefully I haven't done anything dumb, which is certainly possible. Okay. Let's see. 13, 18. Okay, that worked fine. And then when we update 8 and 5, did update right, but again, you could have just literally said x equals 8 and y equals 5. So bad example. Don't do a function like that. And then for our second function that uses reference parameters, it also worked. 64 went to x and 32 went to y. So yeah, that'll do it. Hopefully you learned some stuff. If you have any questions, leave them in the comments below. I'll see y'all later.